put this as a separate recording. So let's look at the questions on basic 42A. Jacob said number what? I forgot the number.
Do you think you can do 3 and 4?
3 and 4. Okay. So let's look at number 3. Okay, actually, I could do a little bit more for you if we have time, right? We can get to the questions at the bottom, maybe which is one of them, okay? So the question in this piece, we are to find the domain, we are to find the inverse, right? We are to find the inverse. And you are given a variety of questions, including linear function, quadratic function, and they are all variations of the basic functions we talk about, aren't they? Right? For example, this f of x equals to x plus 1, no, x plus 4 raised to the power 3. Where did this function come from? Of course, someone created, but if you look at from the perspective of the basic function, okay, I want you guys to see this. In basic function, we have a function by the name of y to the power 3, didn't we? Do we have that function there? Yes? If I vision this x as bologna, and that bologna happened to be what? Happened to be x plus 4. In mathematics, this is called abstraction. This is called abstraction. Or you can also you can see it from a composition's perspective. Okay. So that's one way to see it. From a composition's perspective, okay, I'm going to give you a little glimpse of the composition perspective, which you are going to need for calculus, for chain rule. Okay, you can see this as 2 functions. Okay, I'm going to call it a g function, which is going to be x raised to the power 3. Okay, and then you're going to have an h function, and that h function is x plus 1. And then we're going to compose these 2 functions. We're going to compose these 2 functions. Of course, this is outside the inverse finding, okay? This is outside the inverse finding. I'm just going to give you some tips that's related to your calculus class, is that if you compose it, okay, you can compose in the following way. You can compose G compose H, right? You're gonna get something. Or you can compose H with G. What do you get?
Professor, is that h of x, x plus 1 or x plus 4? I'm not sure.
Oh, x plus 4, sorry, x plus 4. Could you guys compose these for me now? G compose H, H compose G. What do you see? Here, we actually don't have any domain issues, right? Because the domains are all real numbers. No worries.
Would it be the first one, G composite H?
I want you to do both to see what you discover. Once you see composition, okay, once you see composition, you're going to see a lot of the functions you have learned in an entirely different perspective. Then you start to understand why I coined the word basic function and created that basic function table. So please compose G, compose H, or G, H compose G. What do you see? when I was teaching calculus classes, our students have the hardest time, one of the hardest time with chain rule. So all of these exercises I do with you here is to help you to be more at ease when you learn chain rule in Cal. Because if you know how to compose, you can decompose. Okay, we'll do decompose first. Okay, you guys, do G composite H. G composite H, what do you get?
I got bracket x plus 4 and bracket cubed as the end result.
All right, and how about the other one?
I'm still doing that one.
Okay, good. So this is x plus 4, and G is that what you get? So this guy is really the consequence of composition of two very basic functions, aren't they? Yeah. Do you agree with me? Isn't that interesting? Once you see this perspective, let me tell you, all the functions you deal with, they're all composition from the 22 basic functions. There might be some more because, but I think with the basic functions, you can compose any function you're going to see in your academic life while you're in college. They're all composed a certain way because in calculus, we see all the functions in your calculus are composed. And you're going to see a lot of them. That's why some students come back to tell me the function in calculus look weird. No, they don't look weird. They're just being composed. Okay, you just need to get used to it. But anyway, without further ado, I give you these two perspectives. Okay, so let's go to the part that you asked to do. How do we find the inverse?
Two steps.
That's right, 2 steps. Excellent. Step 1, right? So first, you're going to make this y equals to that. Then step 1, swap. Doesn't that look familiar, right? So this is something we've done, right? We have done these for what? For 1 over x, for all the logarithm, exponential logarithm, right? So now, after we swap, what do we get? So x becomes y, y becomes x. Step 2, solve for y. Do we see consistency in these 2 steps? Behind the scene, the domains and range are swapped, but their domain and range are the same. So no worries, right? That's why in your algebra class, when you learn this technique, your teacher did not quite mention the domain thing. The domain was behind the scene. It's at work. Okay, it's at work. It should have been mentioned actually. Even though the swap doesn't result any difference, but the swap happened. If you make a program to do this, you have to do that, right? But anyway, without further ado, solving for y. How do we solve for y? I will take a cubic root on both sides.
That's a good idea.
Right? And then what? One side is the cubic root of x, and the other side, what is it? It's just y plus 4, right? So in the end, y is equals to cubic root of x minus 4. So if this is f inverse is this guy. Okay. That's the, but how do you know you get it right or wrong? How do you know you get it right or wrong? Your teacher didn't give you answer. I didn't give you answer because I don't want to give you answer. I want to discover. I want you to be able to verify yourself. Okay. I remember many, many years ago, I asked the same question to my teacher. So where do I find the answer? So they're not in the back of the book. My teacher says, you need to learn how to do it yourself. There you go. So I throw away that crutch and practice doing that. So I have to find out ways, and of course the teacher will teach you certain ways to verify whether you get the right answer or wrong answer. And I become more self-sufficient. Okay, can I do number 6? Of course, I'll do number 6. All right. So now, how do you verify? I'm going to give you the tool to verify. This is the tool to verify. If you found the right inverse, these should be true. So you have to compose them. So by this time, if you do all of these composings, you will be a master at composing. You'll be a master at composing. And you'll be good when you learn chain rule in Calc. You will ace it. I guarantee. These are the bits and pieces you do that will benefit your future courses. Do you get me? So to verify, you just have to compose again. All right? I'm going to leave that for you. I'm going to leave that for you because I'm going to get to number 6. Okay, if we have time, I will do one of them. I will do one of the verification. So this is for checking if you get the right answer. So we're talking about how to enhance my algebraic skill. These are the pointers I have given you to enhance your algebraic skill. And you need it. You need it very much. It's easy to do. It's easy not to do. Well, some of these are not that easy to do, though, I will have to say. If it's not that easy to do, you must do it. No one else can do it for you. I wish I can do it for you. I wish I can do that for my kids. Guess what? I cannot do it for them either. Right? But anyway, without further ado, so you can see to think about one question, there's so much into it. There's so much into it. Number 6, Number 6, we have to consider domain because this is a function, right? You can also think of this function as a composition of some sort, okay? I'm just going to give you a hint for this, and I'm going to go quickly to get to the, so the composition of this function would be like such as a g, okay, g function, I would probably give you as 3 over x, and the h function, and you guys go ahead to have fun composing, okay? You guys go for it. I'm not going to do it for you. So you do the composing, okay? Go ahead and compose. G composite F, H, or vice versa. Just and have fun with it. And your reward is you're gonna do well in calculus 1 chain rule. Okay, that's the benefit, you know, there's specific benefit. Are there other benefits? For sure. Okay, I'm not going to enumerate them because there'll be so much. But anyway, to find inverse, I'm going to copy and paste this step. So you see the similarity in work, right? The only difference is the functions are different. So this function would be what? Would be y equals to that. So after the swap, so this will turn into x, and this is turning into y. Okay, so we're going to solve this guy for y. How do we solve this guy for y? We also have a domain consideration here. I have to mention the domain consideration. Why? Because that's very important. The domain before the swap, okay, is x not equals to -4. And the range is y cannot equal to what? Y cannot equal to 0. Okay. All right. Y cannot equal to 0. And next, you can see this from different perspectives if you do graphs and stuff like that. So I'm just gonna put that graph on. Sometimes this graph can be a very quick way to get it. If in the future, you know, you see from the picture, you can tell there are 2 pieces of this curve, 2 pieces of this curve. So I can say I'm gonna put -10 here, 5 here, and -10, +10. So you can play with those pictures, and I know most of you guys are pretty, you know, pretty good at doing this. Well, you have a calculator, or you have a, you know, graphic calculator, but however you decide this, right? You can get this, and so this might be a question for you. How do you decide that? We will address that later. We'll address that later. Now, solve for y. Solve for y, right? So how do we solve for y? What you do, you can view this as x over 1. And you flip both sides. You flip both sides. So you have 1 over x on one side, and the other side, you're going to have 1/3 of y plus 4. Okay, and then we're going to multiply both sides by 3. So 3 over x equals to y plus 4. And then in the end, you get y equals to x, 3 over x minus 4. So your inverse function is going to be 3 over x minus 4. So now, domain and range. In this case, you need to be aware of domain. You need to be aware of range. The domain is x not equal to 0. The range is y cannot be negative 4. How to verify? Same way. So to check your answer, you just have to go through these two check this. But this guy, this x is going to be from the domain of f inverse. So x is in domain. Oops, of f inverse. Right? So you guys understand, how do you decide that's from where? Right? Where this x should be from? This x should be from the domain which the first rule that apply to it. Okay, f inverse is the first rule that apply to x. Therefore, x has to be from the domain of f inverse. And this other x has to be from where? Domain of f, because f is the first rule that apply to x. So even though these two axes are the same name, they mean totally different thing. In calculus, you still have the same concept. You have variables of different name, x, u, and stuff. They could mean totally different thing. And we're going to see this. We're going to see more of this in trigonometry. Okay. So I have given you the pointers about these. I didn't completely done the question. I mean, so thoroughly. I want you guys to think about it because those gaps I kind of left there. Our time is over for today's class. I want you guys to think about it, maybe review some of the materials you have learned before. And if you have further questions, please don't hesitate to ask me. Okay. And I will take your questions and then tomorrow we're going to start the trigonometry review. Okay. I think you should expect one more quiz this week. I don't want to give you too many, but at this time, I already give you 2 quizzes. You should expect one more. Okay, related to lectures and related to trigonometry. Okay. And so in the future, I will be giving you quizzes that sometimes the quiz might be related to materials like, 2 weeks ago and so on and so forth. And for example, I might be giving you a quiz on logarithm exponential next week so that you review that part of material. Okay. So without further ado, thank you, everyone. I will see you guys in my office hours or tomorrow.
Thank you, Professor.
Great job. Okay. You can see that this course material is not light, right? Okay, keep up with your good work. I'll see you guys tomorrow, if not sooner.
Thank you.